In this video, we're going to have a look at proof by induction for factorials. So this is quite a difficult example that I saw in a past exam paper. As always, we start with the initial case where we substitute r equals 1, or the lowest number that we can substitute into both sides of the expression, and we want to check if it is the same. In this case, r equals 1 is the lowest expression. 1 times 1 factorial would just be, just 1. And substituting n equals 1 into the right hand side, we get 1 plus 1 factorial, all take away 1. Now 1 plus 1 is 2, 2 factorial is just 2 times 1, which is 2. So that becomes 2 take away 1, which is just 1. So that's good, the initial case holds true. What we're now going to do is we're going to assume that for when n is equal to k, this expression is also true. The fact that when we go from the first term of the sequence to the kth term of the sequence, and we multiply the sequence r times r factorial, we're going to end up with k plus 1 factorial minus 1. Now let's just break down what we're actually doing here. There's a sequence which is given by r times r factorial, and we're finding all the terms of that sequence from the first term up to the kth term and adding all those terms of the sequence together. What we want to show, it does help to write this. Some students don't really want to, but we might as well. We want to show that when we go to a term further than that, so when we're finding the sum of the terms of the sequence from r equals 1 to k plus 1 instead of just k of r times r factorial, we want to show that all of that is just equal to k plus 2 factorial minus 1. Because that's what you get when you replace k here with k plus 1. K plus 2 factorial, all take away 1. So let's go about doing that. We're going to choose a different color pen, and just to start with, let's write down what we're actually trying to express. So the sum of the terms of the sequence r times r factorial from r equals 1 to k plus 1. Well, we can split that up into the sum of the terms of the sequence r times factorial from r equals 1 to k, plus what you get when you put k plus 1 as r. The reason it's good to split up in this way is because this allows us to use the inductive statement that we introduced beforehand. By the way, you might also want to write that where k is all positive integers, for all positive integers k, if you wanted to, just to make it consistent. Now, when you replace r with k plus 1, we get k plus 1 multiplied by k plus 1 factorial. On top of that, we can replace this expression here with this inductive statement that we made beforehand, because we're assuming that this inductive statement is true. We'll then get k plus 1 factorial minus 1 when we replace this inequality with this, and then we add on to that k plus 1 factorial k plus 1 multiplied by k plus 1 factorial. Now we want to get to this expression somehow. The minus 1 is pretty much already there, so I'm just going to sort of move this off to the side a little bit. We want to just leave that where it is, but we want to now somehow show that this whole expression here can be represented by k plus 2 factorial. Well, to do that, we can actually factor out k plus 1 factorial from these two terms. So let's do that. We have k plus 1 factorial, and then get out your big brackets. To go from this to this first term, we just multiply by 1, and to go from this to this second term, we just multiply by k plus 1. So 1 plus k plus 1, all of that take away 1. Now 1 plus 1 is of course just 2, so you can replace the inside of this bracket with k plus 2. And if we break down this sort of multiplication here, k plus 1 factorial is like k plus 1 multiplied by k minus 1. And if we multiply onto that k plus 2, well, that's essentially the same as k plus 2 factorial, isn't it? So that's why we can write this out as k plus 2 factorial, all take away 1, now including that minus 1 that we ignored for a little bit. And that's it, that's everything for this question. Be sure to leave a like if this video did help, and subscribe, I'd appreciate it a lot. Thanks for watching. Thanks for watching your video, I hope it helped. If you have any tutoring inquiries for A-Level Further Maths, be sure to hit my website up at www.excelineducation.co.uk.